petabytes of data. I think from a design perspective, most of those storage software stacks are built not with fault tolerance in mind. So you have to have a few number of nodes or a few number of machines, where if a machine dies or a disk dies, then your system suffers a lot. And I think that is very critical in designing big data systems. If you design your big data system to be fault tolerant, only then you can scale to much bigger sizes. Otherwise, you always get stuck up with high-priced storage solutions that you'd have to pay a lot of money to run your algorithms on.
Third interesting point about, you don't, in many cases, you don't know what question to ask. So you let the data give you the insight to tell the story. Yeah, let's kind of switch gears and we'll come back.
Maybe just one quick comment on that.
Brief one.
Yes,
okay.
Brief one is, I think the perspective here is the data comes from different places in an enterprise. The very same analytics challenges apply to the brick and mortar companies as they do online. So the analytics challenge is one and the same. It's just a question of where does your data reside and do you have the infrastructure, and should be no religion on that.
Good. So what I'd like to do is just open it out to a few questions. We are going to talk a lot about limitations of Hadoop, the hype around Hadoop, other hardware issues and so forth. So if you can basically constrain yourself to kind of what has been talked so far. Yes?
Yeah.
Go ahead.
So my first question is business related. How does it all impact Larry Ellison?
Okay, so this is a great question, and let me kind of capture what he said. There are traditional database. There is kind of a big database and data warehouse, and I'm going to throw BI vendors, and so how does this impact them?
So I'll take this one because I'm not a vendor and I'm not trying to sell anything, right? But just a kind of like market observer, right? Look, the traditional BI world is not going away, right? Right now, it's probably a $30 billion industry, right? And so, you can make a lot of money in that space. I think, the interesting thing is that if you said to someone now, how big is the big data space? It's maybe 20 million, maybe 30, maybe 50. But it's in that sort of order of magnitude today. If you said, how big is it going to be in 10 years? I think it's going to be way bigger than that $30 billion for the traditional BI. So how does it affect the traditional BI vendors? Well, first of all, they have a business and they're sitting in a market that's having slow growth, right? The CAGR is pretty slow in that market. So they need to be looking at this other space. And you just see recently Larry talking about his big data appliance. And I saw, and Microsoft. Microsoft's PDW has been coming soon for about 3 years. I saw somewhere out here someone with a badge from the Oracle Big Data Appliance. So apologies. Yeah, there you are. Right? No apologies here, but so I think you're starting to see that the traditional vendors are going, we need to do something about this big data space, right? You look at a lot of the vendors. There was a big acquisition spree a year and a half ago, right? With like Greenplum, Vertica, Astrodata getting snapped up. So the traditional vendors are seeing that this is an opportunity, but I don't think they see that it's actually coming faster. It's coming faster than they expected, right? And they're actually not moving as fast as they need to.
I'm glad you're here, by the way, because one of the challenges with this panel is that we're all drinking the Kool-Aid. And that doesn't make for an exciting conversation. So I sure hope you'll ask a question.
Hi. So let me offer another response as well to the question. I think that's a good one. It goes beyond Oracle. I'm not worried about Larry Ellison's wealth. I think he's got enough of that. The question there is and this is what big vendors have been proposing is, especially the relational intensive guys, is to take Hadoop data and feed it into a relational database at the end of the day and continue to use your old BI system to get results from it. I think that's the wrong approach to do it. If you're going to solve the problem one way, do it one way. Don't do it both ways. So if you have Hadoop data, there is no sense in exporting that, putting it through a Hadoop loader, putting it into a database, and then using your IBM Cognos. And I have nothing against those approaches, but I really believe that one approach over the other is a conflict.
So says a vendor in the big data space, but from someone who's invested 30, not me personally, but from a company who's maybe has 30 years worth of investment in traditional BI tooling and all of their reporting and all the rest of it. The adoption in an enterprise, is going to naturally, at least initially, I think, be in that model, right? And I think that's what we're seeing out there, right? People are saying, look, I've already spent like, millions and millions and millions of dollars on business services or Cognos or whatever it is, right? And so I want to feed into this environment. I don't disagree with what Karthik is saying, which was the future is going to be, there is a new stack, right? And it's going to be a whole industry-defined stack. But at the minute, if we're not going to drink our Kool-Aid, we're super early. Like part of the question here was, are we kind of like in the trough of disillusionment? And maybe that's the next slide, right? So kind of like preempting the next slide, because we talked a little bit about this backstage, right? I think there's a huge, tremendous amount of promise in this space. Clearly, all of us sitting up here on stage are either using it or, trying to build companies around it. But if you take a step back and say, look, okay, people have been around who have a bit of grey hair and been around for a while, right? There's a lot still to do to actually deliver this as a market, to deliver this as an industry, right? To deliver all the technology that's needed to really derive huge value out of it.
So there is getting a lot of connectors, to SQL Server, various databases, and so forth. And
Yeah.
so, my question is, do you see sort of Hadoop as sort of a place for data to stay for a short period of time and then go somewhere else?
Yeah, so I have a number of different thoughts about this. By the way, the first thing with respect to traditional database vendors and Hadoop, I think the only thing I would say that I felt a little sure in is I think that the whole porting MapReduce to database trend was one of the sillier responses to this trend. I think that completely missed the point of what Hadoop was about. The whole point is MapReduce lets you work on something without a schema, and so to drop it on top of something with a schema was the exact opposite of what you want to do. I think some of the comments. So we Cloudera, I think one part I think all of our founders, or original founders, came from Facebook and Yahoo. We're like, this thing's amazing. It's going to take over the world. It's going to hold all your data or whatever. This was the pitch 2 years ago. So we really sounded crazy at that point. I think realistically, organizations own a lot of stuff. They are invested in certain skills, certain technologies. That those things don't change readily, and frankly, Hadoop's not good for all things. So the idea is Hadoop is going to need to work with other systems, interoperability. That's a whole other class, right? So one of the challenges with Hadoop is tools and applications, right? So not every person's a data scientist. How am I going to get useful tools and applications to work with this? And again, there's some great innovative new things that are being created. There's whole companies starting that are net new tools, but hey, there's a lot of users. There's like a couple 100,000 people trained up on Informatica Power Center. There's a couple 100,000 trained up on MicroStrategy. Do those people all have to throw all that stuff out? I think there's room for both, right? There's room for both in both cases. I think the only debate that's going on right now is that if you're going to own multiple data management technologies. The idea that there's one grand system that's going to govern everything, that's never proven out. The question is only whether Hadoop is the hub or Hadoop is the spoke in this web of things. That's the only thing left for debate, I think, at this point.
Question?
Over here.
Over here.
Over here.
Okay, go ahead.
So along the lines that you've been talking about, the baby elephant is growing and starting to trample a new forest. Business enterprise applications being provided as software as a service or platform as a service or infrastructure management or data as a service. The question I have is, what challenges do you see in indexing a multi-tenancy kind of a database for enterprise customers who are running business mission critical applications on that environment? And a related question would be, what challenges do you see if you try to run analytics across the entire consumer base or your customer base on some interesting things that you can share with the customers while still maintaining their privacy?
Sure, I'll take a first stab at it. I think multi-tenancy is a very hard problem. It is not directly related to big data, as far as I can tell, because multi-tenancy means basically sharing resources between different tenants on your same hardware or your same software stack. So that's a very tough problem, and I think most of the big data systems that I know of right now don't try to solve that problem very well. You want to add it?
I'll add to that. Right? I think this is one of the areas, real fertile areas of growth that we're going to see in this marketplace right now. If we just take Hadoop and let's be clear, right? Hadoop is certainly the leading one, and maybe the one that's kind of like crossed the chasm, as it were, right, in the big data space. But there's a bunch of other data stores out there for different kind of like niche areas, right? And when we talk about big data, it's all of them. But here we're talking a lot about Hadoop. So if we focus on that, right? Compare Hadoop to, say, something like Teradata. Teradata's got a workload management system that's been in development for 15 years and can deal with queries that are kind of like sub-second all the way up to like a week, and partition all the resources and deliver a quality of services and an SLA. Those are investments that we as a community need to make on top of Hadoop to get it to the point where, if the vision is it's the hub, that's the type of kind of like workload management and resource management we're going to need to do on top of this platform.
I want to just go back to the traditional data warehouse and BI solutions. Do you see a world out there where the traditional vendors continue to dominate the big data structured world, and there's a new class of technologies and vendors that deal with unstructured, semi-structured data?
Yeah, I definitely believe that will be the way things start off, because I think pertinent to the previous question here, the big guys are going to have a play. Everybody wants a piece of the pie, so they will have a play. They will have Hadoop appliances or distributions or one thing or another. But the transformation or the hybrid is going to take time. So we are definitely going to see a bit of a chasm between the traditional approaches and people like me, condemning the hybrid approach, and then the new approach. So the online companies have the luxury of starting off afresh. So they will begin with do-it-yourself approaches, and we talk to a couple every day who do some sort of do-it-yourself approach using Hadoop. But over time, what they are going to transition off into, and this is just my way of looking at it, is they are not going to want to continue to be the Hadoop experts. It's not easy to have full-time people on it. You'd rather be developing your app and relegate some of the big data management and analytics to people who are experts in the space, people meaning technology. The big guys are going to have to figure out how to play into that space. Until that time comes, I think there will be a divide between how you manage structure and how you manage non-structured, as we call it, data.
I think that for where we're at in the market right now, for Hadoop and traditional enterprises, that unstructured data is sort of the gateway drug for most enterprises. So I think if you talk to a traditional corporation that's got gobs of high-end data management gear, and you say, would you consider putting 500 terabytes of log files in that, right? Most people are like, no, that doesn't make a lot of sense to me, right? I think one customer said, it's like, I've got a Ferrari here in my Teradata, my Oracle, whatever, and I've got all this dirt here. I need a dump truck. I don't need to put all the dirt in my Ferrari, right? So, and for Cloudera, that's actually what I'm representing a net add to the database vendors, because it means that you take the dirt and then you sift it through, and eventually you actually toss some more stuff in your Ferrari. So, I think that's where it started, but I don't really think it's a useful long-term demarcation. There's just as many use cases I see now where people are iterating on structured data. The other reason why it's a big gateway drug is that the unstructured stuff is just way bulkier, right? So for every record or bit of information, unstructured stuff like text and images and whatever, it tends to take up 10, 20, 50 times as much space per interesting bit of information. The transactional stuff, like what was the purchase order I received, it's really compact relative to the amount of meaning that's packed into it. So that means that you're not going to hit a scaling limit, for a traditional enterprise anytime soon. You may hit a flexibility limit, but that's a different question. That comes back to these ideas of novel questions, which requires a certain class of expertise and a specific use case to catalyze the need to ask the novel question.
I just wanted to add one more thing around this. So this may not be very timely because Netflix, we all have questions around the business strategy that Netflix is adopting now. There was a point in time that I read an article about how Netflix became as successful as it did. The CEO of Netflix basically had given an interview and said, well, there was a point in time where I had created competition within the company. So the DVD business was competing with the online streaming business. And so he already saw beyond the curve, basically, and said, well, what's coming up next? And to Todd's point, we have seen in the last year or so the big data play or big vendors have started to acquire these smaller units, which are sort of venturing out in the space of using Hadoop or related technologies to manage big data. And so, unless they change the game, as the game is changing, and so the successful companies will have to change the game and adapt to this new world. And in my view, otherwise, companies fold out like that.
So I have a question. If I'm looking at it from a marketing perspective, if I'm VP of marketing, and I'm trying to figure out what kind of business analysts or market analysts or product managers I need, right? What is the implication of all of this techie talk, in a way we are having on business people who are saying, okay, what kind of people do I need? What kind of skills do they need? Or all of this techie stuff will kind of figure out through machine learning what it is, and these guys will just implement it. So what is the implication on if you are a product manager or looking for a product manager, what skills will become more important, what will be the shortages, and what do we need to do about that?
So I'd like to jump in on that because this is one of my kind of like favorite pet topics, right? Right now we have this kind of like new job title called the data scientist, and it's getting a lot of play, in and around the world, and in and around the web, and in and around big data. Right? And the data scientist is someone who, at the minute ends up writing or programming, algorithms to go and sift through the data. But realistically, my take on this is that, if you fast forward to the end of the decade, the data scientist has now disappeared. It's just back to being a business analyst. Because the data scientist right now is really a kind of like point in time where you have programmers, or, the equivalent of DBAs who would write programs, and they, these data scientists are now those types, but they're focusing on the data. Or you have business analysts who used to sit in Microsoft, OLAP services or whatever it is, or Excel, and used to write stuff in Excel, but they can also program, so they're now a data scientist. But the key for us as an industry is to say, look, the majority of business analysts don't know how to program, and we need to get back to the point where every business analyst can actually derive value out of the big data without having to be a programmer. And so I think in 10 years' time, that person, the data scientist of today will have disappeared again. We'll be back to just business analysts.
So you have this business scientist, the big corporations that I've worked at, so as I get acquired periodically, there's someone sitting in the corner, an exotic person, in many cases in finance or someplace like that. Do you see, every business user basically becoming an analyst?
So, are you asking Todd specifically, or? Okay, so I have the same perspective as Todd. Yes, the title of data scientist has got a bit of glamour right now. I feel that it's a bit of a transition phase that we are in, where the tools are not sufficient. They don't bring to the product manager, to your point, whoever asked the question, they don't have enough data at their fingertips. When I was running product management for a division at NetApp, I relied on the financial analyst and a bunch of other people who provided data, one from the customer support area, one from the revenue area, and together we try and interpret. It's a long process. And I have to know the questions, and Ravi brought this up earlier. You have to know what the questions are that you want to ask the system, and then you get the answers. So both are hard problems. So really it's incumbent on us to provide solutions to the business user to make it self-service. That's really where the game is at. So if you have self-service analytics, and to Todd's point, you don't need programming expertise, that's really what's needed. So that's lacking today. So data scientists are filling in for that position. But over time, with the advent of tools, self-service tools, that's going to go away.
I'm going to tweak. I'd like to add one twist to that. In my mind, so I fully believe in the need for applications, and all the setup for what they just said is true. So I don't want to take away from that. But the data scientist person just went by a different job title before. At least at Cloudera, the people that we see that are happy in Hadoop is if you find SAS users, like SAS users are pretty happy in Hadoop. Like and they don't need. They typically. They're like, first like, can I have SAS for Hadoop? I'm like, sorry, there's no SAS for Hadoop. And they're like, oh, then they learn about this thing called Pig and this thing called Hive. I'm like, oh, this is actually, compared to SAS command line, it's really not that much more technical. It's kind of scripty, it's not really programming. And for the kind of people that use SAS, like, it's actually not that distant. And if you came from the high performance computing or MPI world, Hadoop is crayons compared to what these people had to figure out to do with like platform computing and these types of things. So there is a cadre of people that actually Hadoop is a relief for. It is simpler than the life they have today. Now, does every corporation employ armies of SAS people and armies of MPI people? No, right? Are there thousands of these corporations? Can Cloudera make a very good living in the meantime until the next generation of apps get built? Yes, we're doing just fine. We're not starving until these guys go away. So there is this crowd of people that existed before Hadoop. They're going to exist after Hadoop, and they will. I think that they will command a premium salary in the future that they would not command before, because the leverage on their mind is so much better than it was before. We hired a few people at Cloudera to play this role as kind of like data science ninja people we could drop ship into a few customers. And we talked when those guys came out of Google. He's like, yeah, like it was kind of fun being at Google. Like I could have a good week. A good week was a $100 million week. I could find $100 million for Google just because I tweaked one algorithm and the yield improved on a certain class of ad in a certain situation. So the return on a mathematical mind now for data, in some certain fields applied right, it's as good as hedge funds, in terms of what you can do with a bright person. I don't think that's not mainstream. That's not what thousands of enterprises are going to have. More of this stuff is going to get cookbooked. It's going to get turned into apps. It's going to get domain specific, and that's how the everyday person is going to do it. But I do think that if you've got the stats meets CS kind of brain, the world's your oyster, and there's only some of those brains in the world. Like that supply only grows at a certain rate, but the ability of those brains to generate a lot of value for profit and not for profit is higher now than it's ever been.
So I just wanted to add one more twist to this. Basically, I completely agree with Todd's view on this. Data scientist is the new black today. It so turns out that we are in this transition phase where we moved out of the SQL world. We are seeing volumes of data that we have possibly never seen before. Maybe we have. I'm not that old, so I don't know. But so the notion is that, and Charles also mentioned the fact that data scientists are commanding the kind of salaries that they're commanding primarily because with the advent of new data and the new technologies like Hadoop that have enabled, basically it's like giving a child a little toy to play with, which is basically, this is my new toy. I love data, and I want to analyze the shit out of it. I'm sorry, is that? But anyway, so data science is sort of filling that gap, where in which the tooling is not mature enough that you could do conventional BI kind of analysis, and the engineering, the classical software engineer doesn't have the necessary chops to interpret and analyze the data. So this hybrid blend of data scientists are what is the prominent players in this market today. But as we go forward, when the tooling improves, I would second the thought where conventional BI people will have to start to play a much meatier role than in this transition phase with what they're playing. The other aspect is to build systems that now generate tremendous value in terms of revenue dollars for companies like Google who are analyzing troves of data to do ad targeting and so on and so forth. You'll have to build systems and hire extremely good technical minds to build out software systems that scale. So we will see this division where BI folks will specialize in the analytics side of things, and then there'll be software engineers who will actually rule the roost when building out the software stacks.
So let me ask you about that, because I think I heard Karthik talk about do-it-yourself, and a lot of the focus here was on the, if I were an undergraduate in computer science, would I be doing advanced statistics and Bayesian and neural networks, or would I be doing system software? And so do you see the Oracles and the Teradatas and IBMs and HPs of the world delivering sort of solutions, appliance solutions that kind of complete hardware software solutions, so that not Facebook and not Google and LinkedIn, but the next tier of companies are not doing Hadoop themselves. They're hiring the data scientists, but they're buying the systems from, say, someone like Oracle.
What do you think? Clearly the traditional vendors are going to be delivering these kind of like vertical packaged appliances. I think that we've seen a resurgence in the data industry for purpose-built appliances, right, in the last 5 years. I think the interesting thing with the traditional vendors, though, is that they're still playing catch-up to where, you know, the thought leadership and the mind share is around what you want to build with big data. So it's not just as simple as saying, oh, I put Hadoop on an appliance and I've got some nice disks and it just works, right? Because Hadoop in and of itself, and even a lot of the stuff we saw on the slide there, is plumbing. It's plumbing level stuff, right? And so right now, even if you deliver an appliance that has the plumbing on there and it's nicely packaged, or you go to CD and all of the plumbing is nicely packaged, you're still left with building the applications on top of it. And so where I think, if we look back 30 years and say, look, 30 years ago, a number of people invented a database and SQL came along and gave us a solid platform to build applications on. We saw these archetypal pattern applications appear, whether it's Salesforce automation or customer relationship management or supply chain management or demand chain management. There's a number of them. Right now we're at the point in the big data world where we have this plumbing layer and we're doing pretty well in improving that and making it all work together nicely. But the next phase is going to be, we're going to see these archetypal applications start to appear in big data. Right? Optimization, advertising optimization might be one. That might be a subset of just personalization, right? We're going to see these appear, and we're going to start to see, common patterns that apply across verticals. If you look at the kind of, the online companies that are represented up here, advertising optimization is pretty much, or optimization of some content, is pretty much what drives their business. Right? But market basket optimization is a similar class of thing. It's just, it's a different industry, right? So the question that I'm, kind of like focusing on at the minute in the work that I do is, what are those archetypal applications that are going to appear?
Yeah, I think traditionally, my perspective has been that traditionally for warehouses, it wasn't a very engineering-driven, how should I say, philosophy. In some sense, it's like a post-processing of data. What I have seen with big data and Hadoop is that you actually use it as an experimental platform to do kind of A/B tests. So what you do is you kind of put out some new features or new products and then quickly analyze how people are reacting to that. And because your feedback cycle is very short, you can afford to play it wrong many times because you can quickly fix it. Whereas in a traditional warehouse system, it might take you 6 months to figure out that your campaign is not working well. Whereas in Hadoop land or in the new big data model, we are able to experiment things very fast, and so we can also use it as like an A/B test kind of platform.
Let's take some questions. Yes.
So I think we touched upon unstructured data, and I think Karthik's comments was around the confluence of people and usage and real-timeness. I think if you look at the social networks, Facebook included, the network is the warehouse. There's a lot of data there or insight there that needs to be extracted. So are you guys looking, what kind of use cases are being developed on Hadoop that actually combine the world of a social network and business with structured data in the warehouse and looking at, using insight from one to the other versus moving queries back and forth. I didn't hear any examples when I looked at InSwitch and a couple of this, but none of those examples cross the two worlds.
See, one of the things I'd like to point out is behavioral analytics. So no matter what realm of business you're looking at, the user or customer or audience behavior is key to driving business. So that's one use case that I'd like to point out. There's a couple more, but I'll let the others chime in. But speaking a bit more about that use case, behavioral analytics is about how your audience, the target market that you're going after behaves. It could be an enterprise learning product that you sell, or it could be an online merchandise that you're selling, or it could be a gaming app that you want more users to be playing. No matter what, knowing what that individual's behavior is on the site, and it's one thing to have summary analytics, which traditional BI players do, and everybody does, which is aggregating totals, like total time on site, total number of visitors, total number of clicks. That's all good, we need it too. But we need the individual layer, the layer below, which is what led to a certain action being taken. What was the sequence of steps? how many people are clicking on this first and this second and this third. So we call that individual user behavior analysis. And it's good for two reasons. One, for the very reason that you asked the question, which is to know how to and when to enhance your product offerings. That's one. The second, there are some companies that also believe in brand ambassadorship. So they need to know what their top users are doing so they can promote them and say, here's my...
Correct me if I'm wrong, I thought your question was more about you have data in very different type of sources, kind of traditional structured sources and then kind of text streams coming in.
I'll give you this is a public record example of one org. So eBay. So eBay wanted to have, when people looked for products on eBay, they got a huge catalog of things that aren't for sale at any point in time. They wanted people to be able to find what they're looking for so they could go buy something. So it's directly related revenue. Think about the data they're working with for that exercise. So you log in, they know who you are, they know your purchase history, they know if you're male or female, so it's traditional structured stuff, right? How much you bought, how much things cost, structured all the way. And they know that then you search for something. So you put the word, you search for Cobra, right? You put the word Cobra there. It's a string of text, right? So it's unstructured, right? And then what they want to know is like, well, what do you really want? Did you want Cobra like the pet Cobra, or do you collect G.I. Joe figures? You want Cobra Commander? So they look at all these different pages that got sent back. So the pages where what was presented to you was what products were sent back, but also what order they were in. So some of that stuff is structured, some of that's not. And then you click around. So first you look for one thing, and then you double click and look at the image, and then you back out again. All that data, that was registered as probably as weblog data. So all that came, and it was just strings of text that are re-sessionized back out. And then sooner or later you bought something, hopefully, right? And and then after that was a normal purchase transaction. They got your card swiped, the payment. So in that chain of events there was some things that were just pure text, and they had to do text mining and infer meaning from that. There were things that are highly structured, your profile, they have a product master, they've got an order history, and they're bringing those two things together to fundamentally say, can I present you with better results so that next time you actually buy something? So I think that's a pretty concrete example. There's some other ones I can't name of like consumer branded products companies. Everyone's jazzed by the idea of like, what do they say about me on Twitter? And what does that mean about how much actually gets purchased in a local market at a store? And so people are doing stuff like that. It feels a little bit like, gee, wouldn't it be cool if? As opposed to, I feel like the eBay case is like there's real money that gets tied to the difference in the search results. And that's a good example of text, machine-generated data, and transactional data all rolled up into one ball.
So I just wanted to add one more. I mean, it's in the same vein as eBay. Amazon, for that matter, has multiple initiatives that are public now, in which they're trying to sort of take in social network data and tie it back into shopping experience. So that's a classic use case where basically you have the new data warehouse that you talked about, which is the network, and then the conventional transactional records where people are buying stuff, and how do they combine them together to provide a better experience with respect to the user experience as well as how it translates back to better revenue for the company. So that's a classic example.
One thing I just have to say is out of gratitude is the companies here. Thank you so much for making your use cases public, because I can't tell you how few things I can talk about, and it really helps that there's some big live, revenue generating use cases that catalyze people's imagination for what's possible here.
So let's switch gears, and we'll come back to some questions. So I want to sort of bring up the cloud, and so Hadoop is dealing with large quantities of data, and so if you have this in a place, let's say in a public cloud, let's say it's in AWS or someplace like that, Amazon's cloud. How do you deal with the movement of this big data? And sort of a kind of a similar question is, even if you're doing it on a private data center, big data by definition at some stage is going to outgrow the data center. So how does it kind of go across data centers?
So I mean, the simple answer is you don't. Right? I mean, if you're generating petabytes worth of data up in the cloud, the Amazon cloud, why would you ever think to bring that back down into a private data center? That would be the most expensive, stupid thing you could do. Right? What you would do is you would drive your analytics up there, and if you had to, you might take some results and join them with some results locally. So I think kind of like at the root of your question maybe is like, look, the cloud is here. it's mainstream at this point. People are building applications up there. How do you deal with data in your hybrid cloud, whether it's in your private or public cloud location? And I think that's about thinking about data not just as this kind of like static file, but as this kind of like, live data flow that needs to move through your entire ecosystem of tools, right? The future, I think, of big data is not just about throwing this stuff that's going to be just dead and static into this kind of like warehouse. It's about building a data flow architecture that allows you to deal with stuff in real time or update stuff, whether it's scoring or modeling or behavioral analysis and behavioral targeting, as well as in the end landing it somewhere where you're going to do this kind of like trending analysis and data science.
So, what do you mean by cloud in this sense? Take for example, like the Amazon cloud, for example, if you look at the storage thing, is it very similar to like what Exodus did when they had storage as a service? So what is the difference? Because people keep asking this question, what is a cloud?
So I'm taking a situation where there's a whole, including a Hadoop and a MapReduce infrastructure in Amazon, but the problem is the data is not there. I mean, it's clear if the data is sitting in Amazon also, then you got lucky. But what if the data is not there? Because in some sense it feels like Hadoop is a life extension for people like Oracle and Teradata and the old bloated complex software folks. And so is there a cloud play here? Because here the problem is data, and moving large amounts of data requires significant enhancement, innovation, and networking.
Right, yeah. So if you have an application that's already hosted in somewhere else, then you could definitely run your analytics over there. Right? But another difference that I see for cloud, when people talk about the cloud versus older storage systems where we used to have storage as a service, right, at some point in time, like the .com time. But the difference that I see is that when I talk about the cloud, to me, it feels as if it is very elastic and it is very fault tolerant. These two things I think weren't there when we had storage as a service earlier. So now what it means is that data is replicated somewhere else and it's very elastic. You can buy more storage or more compute as and when you need it. So given this definition of a cloud, it doesn't make any difference whether the cloud is public or private. Depends on how important your data is or how secure you think you need to keep your data. But the analytics and the processing probably happens the same way, whether it's in the public cloud or in the private cloud.
I'm just going to add one thing. I mean, I think this is a great question, right? And this kind of like gets to the heart of like, the model of Hadoop. The model of Hadoop is you have so much data that you can't move it to the computation, so you're going to move the computation to the data. And that's exactly what you're going to do in the cloud. If you generate all of your cloud up at Amazon, you're going to move your data computation up there. If you're generating it all in your private cloud or locally in your data center, that's where you want to compute against it. The cost to transfer the data is going to far outweigh any other cost when you get to real big data size.
So the location of the data is a critical factor here. So let's kind of talk a little bit about hardware, and maybe Dhruva, you can give us a kind of a 1-minute overview of what a typical Hadoop cluster looks like.
Sure, I can tell you a little bit about our cluster infrastructure, what kind of hardware we use. So I'm talking about like a medium-sized cluster that we have, probably around like 40 petabytes or so. So we have big machines. So all these are commodity machines, but each machine has like 8 CPUs. So it's not one of those cheap, like really low-end boxes, right? It's kind of in the medium range. Each machine, most of our default machines have like 12 disks associated with them. And each disk used to be like 1 terabyte a couple of years back. Last year it was 2 terabytes. These are all SATA disks. So this year they're coming with 3 terabytes. So one machine has 36 terabytes of data. So if you put like 3,000 or 4,000 of them, you have a really big warehouse. Just because each of these machines are quite big, right? Each of them is like 30, 40 terabytes of data. The networks in our cluster, all the machines used to have like a 1 gigabit network card connected to each node, and now they're becoming 10 gigabits. So networking is improving, network speeds are increasing a lot inside the data center. This is all inside the data center. When you go across data centers, then it's very different.
So you guys are doing 10 gig throughout now?
Yes, so from each node, there's like 10 gigabit network coming out of each node. This also has implications on how cloud design is done, because What it means is that now if one machine dies, you have lost one replica which is worth 36 terabytes. So you need to re-replicate this 36 terabytes quickly enough so that your mean time to failures, between failures, is kind of low to keep your data intact. So there are a lot of design issues that come when things are becoming bulkier and bulkier.
Are you really using the disks for capacity, or are you using them for I/O?
So most of our disks, okay, so we use SATA disks, and there the IOPS hasn't changed much. It's like 100 or 150 IOPS for the last 5-10 years or whatever. So we use mostly for capacity, and Hadoop is very sequentially scanning kind of system. So there are no indexes built into Hadoop. So when you do a data warehousing query, it's mostly like a full scan of your data. So that's why we are not IOPS bottlenecked, because it's all sequential scan. But we are mostly bottlenecked right now on storage capacity.
Here's an interesting, kind of follow-up from the previous question, right? At the point where we get to Hadoop being able to be multi-tenant, support multiple mixed workloads, I think we're going to see the hardware need to change, because, it will be not just a full file scan, it will be a kind of like random seek, with multiple queries coming through, right? And so I think we're going to see the footprint change a little bit in the future. Not now, because the software's not there to support it, but if you fast forward kind of like 5 years.
Yeah, I think there will be some indexes that will kind of get built into some of the layers above Hadoop, just to access data better.
Do you think, Drew, I'm curious, it's like you said, the trend has been more drives, denser drives. Do you think there's a limit to that, or do you think it just keeps going? That if someone said, like, can you go put, 60 terabytes of SATA in a single box, do you still think that's a good idea, or at some point do you think more boxes is the better way?
I think it's the ratio of your network versus your disks, which is important. Also, I think what I have seen is that our whole society is kind of becoming a very data-driven society in some sense. So I think that there will be a lot of cold data that people generate, that people don't look at it for long periods of time. So just increasing the disk capacity actually lets you hold a lot of cold data, whereas your accesses are not as big as the amount of data you still store.
I think a lot of it's about the kind of unit of failure, right? That's I think the root of your question, right? And so I think, previously in most deployments right now in Hadoop anyway, as Drew was saying, you lose a node, a server, you got to replicate that whole server. The disk fail in place work that's happening will obviously bring down that kind of unit of failure.
A NIC can die, a motherboard can die. There's so many things that can die that it still feels like the penalty you pay for losing a node. That we're gonna right now. I think like 12 times 2 terabyte is kind of where we're at. I really wonder if there's going to be 24 times 4 terabyte. I think at some point we're going to hit a limit where it's going to stop making sense.
I think it's going to come down to kind of like the cost, right? Where it's what's the cost of the node versus what's the cost of having to rebuild that node or rebuild that data. I think Drupa's point about cold data is very, very valid, right? At Yahoo, we had about 200 petabytes worth of data, and I can tell you that the majority of that was not hot, right? But we used to basically buy nodes when we spec'd out clusters based on capacity. So we had oodles of CPU left over and really, oodles of I/O. And realistically, great places for investment in the community are kind of like compression and better storage, formats to take better advantage of how you pack the data down.
So what's interesting is, this is all cheap SATA storage. And so the disk vendors do well here. What about shall we say, the traditional storage big guys, the EMCs and HDSS? Is there room for centralized storage, NAS, SAN? Is this never going to, these are just kind of old technologies?
I think you need some centralized management at the end of the day. It doesn't really matter whether your storage is all centralized in one place or not, as long as you can manage all your storage from one place.
I just don't see a world where anyone ever is mounting Hadoop on a SAN. I think we can safely say that that's over, which happens to a lot of people mount databases on external storage. So I think that part's done for.
I think the other aspect of this is that one of the reasons why Hadoop is taken off is the cost of operation and essentially the cost of the hardware that you put in. And so going back to these traditional systems, it's just counterintuitive that you're regressing in some sense.
I think the interesting there, is like if you look at the cost curve, right? So one of the reasons I think Hadoop has been so widely adopted is because, as Charles was saying, it's open source, right? So people are kind of like, oh, that's free. and then I can buy commodity hardware. Okay, that's super cheap. So the barrier to entry is very, very low compared to going and getting traditional database and sticking it on some SAN and expensive big iron, right? So people are like, yeah, well, I'll plow data into that. But as you get a little bit more sophisticated, then your cost curve starts to increase, right? Because then you need ops people, and there's not many of them around. And if you try to hire a kind of like Hadoop ops person here in the valley, they're like gold dust, right? There's probably like a 10x skill shortage. Yeah, I mean, there's probably like a tenth of the people that we need in the valley just to support all of the people who want to do Hadoop here, right? So if you're looking to if you're looking to retrain right now, go and learn Hadoop, do it tomorrow, right? You'll be in demand for the next 10 years or more, right? But so I think the cost is kind of like a deferred cost, but in the end, you do start to get that cost because you need a team to keep Hadoop up and running and care and feed it and build their applications and be programmers and do all the rest of it. So the traditional vendors, what they like to point at is kind of like TCO, the lifecycle TCO. Right? And I think as a community and as a technology stack, we still have a lot of work to go, I think, to kind of like get to the point where you don't have that deferred hidden cost.
Good. Let's take some questions. We'll come back. Go ahead, please.
So sounds like, is this a good time to talk about
Yeah.
limitations perhaps of Hadoop? But before we do that, what do you guys think about semantic databases and generally RDF? And then what can big data not do?
That's a great question. So does anyone want to answer the first question?
No.
Okay.
I'll answer the second part.
I'll talk to RDF, right? So I know a very, very well-known telecom provider, announced a Teradata, tried to put RDF into a traditional database and completely failed. Right? RDF is not very, very well suited to a traditional database, right? What do we think about semantic databases? Interesting niche at the minute, but there's lots of interesting niches, whether it's graph or semantic or RDF triplets or the rest of it, right? There's a huge chunk of these kind of like niche databases that haven't crossed over to become widely applicable yet.
So the second part of your question, I think there's going to be lots of opinions. So maybe let's start with Charles. What is it that Hadoop doesn't do? And you can see that, there are alternatives to MapReduce, there are alternatives to Edge-based, there's a whole wealth of NoSQL databases. There are just some things that Hadoop is not good for. There are also some alternate stacks that batch processing stacks that are coming out.
I'll take if you take the whole data management world, first of all, it's cleave off OLTP. So transactions as enterprises understand them. I know Drupa we'll see if he begs to differ, but transactions as multiple enterprises understand them, which is like ACID, multi-row semantics, these things. Hadoop doesn't have anything resembling that today. And I think it'd be a long, long ways before someone consider that. So that's about, probably half the database market that is untouched. Within Hadoop, I think the next thing you'd say is that if you're doing normal drill down query analysis, the stuff that you traditionally did in a data warehouse or data mart, like what was sales last week by store and these kinds of things, Hadoop does not give you the same low latency iterative ability that a traditional data warehouse does for that. And Hadoop is actually, from my point of view, is even stronger contrast when you consider how much stuff is going to in-memory. So that same kind of what was sales last week by store, that's all getting tossed up into, it never touches disk anymore, so it's really, really quick. So that's another one. The other one, which is, I think increasingly people are pointing out, and there's a bunch of development going on in the open source about this, is people are shoveling a lot of workload into MapReduce. That's a little bit of a stretch, right? So if you look at Hive is a SQL-like layer on top of Hadoop. So you basically write SQL, it compiles into MapReduce, executes, People do the math on this, and compared to a query engine, it's roughly about 100x less efficient than if you had an optimized query engine. Graph analysis, there's about 100x loss through the MapReduce paradigm compared to native engine. MapReduce is actually, I think it's a testament to the economics of Hadoop and the flexibility of MapReduce, that people are actually willing to give up a lot of efficiency, and they actually are pushing way more workload through that framework than it was originally designed for. So I think that's the other thing, is that it's actually less. There's a lot of proposals now for more optimized engines specific to different domains that are going to get brought to the storage. So that's probably the other thing that Hadoop will get good for over time, but it'll change the definition of Hadoop.
Yeah, I think that the design points of a traditional warehouse system versus Hadoop is different. Hadoop, the first point that we always, from day one, we kept in mind was scalability. Next one is fault tolerance, and the third one is kind of performance. Whereas most other traditional BI systems, the first goal is performance. So both of them are trying to solve the same problem, but from two different angles. So that's why you see these different behavior or different workloads are suitable for different kinds of systems.
So I just wanted to add a couple of points to what Charles said. There's a new paradigm that's emerging, and this is one of those things when pioneers of the newer systems have actually started to move on. There is a lot of open source development in stream processing. So Twitter is generating like billions and billions of tweets a day. Well, I don't know how many billion, but whatever. So internally at LinkedIn, our systems were communicating to each other. You have 200 plus services which are generating basically more than 1 billion messages when people come to the site, they click on something, they share a news article, they make a connection, and so on and so forth. Roughly about 1 billion events a day. And so there's a new sort of series of applications